I muted myself when I shouldn't have. Onion?
Cheese.
Hi! My lights are working, but this time the reason why I'm 2D is because... Well, it'll be revealed in a sec. Why is there so much cheese on me? You can slightly actually see the slices of cheese before they move away, but mostly you just see the shadows. Hi! Why am I in jail?
Shite.
What is this? I'm moving around for dramatic effect, but you can't really tell. I mean, you can tell, but you can't.
Cheese.
Okay, hi. There we are. Amazing. You've jailed the 2D cat.
Cheese.
I hope you're happy with yourself. Hope you're happy with yourself. Look at this. The fucking cheese by itself gets me every time. Anyway, hi. Welcome. Nah.
Fromage.
Nymph, thank you very much for the resub. And welcome in, Nymph. Hi. 3 months already, sheesh. Sheesh. Hi. And welcome in, Beat and Fox. Yeah, I'm afraid I won't be doing sleepy crashy distance running today. Well, maybe I will later. Like off stream on my Discord, maybe. In voice chat. Wow, what a perfect opportunity to show myself. Ta-da!
Oh my god. Well, Chaos has made me evil. Living up to the name. Hi! Welcome, Chaos. Welcome, Exia and Fox. Wait, why is Reva not working? Hello? There it is. And Stu! Hi! And Bill! And Alec! And Azrael! Oh my goodness. Hi, and Luna Dream! Welcome. Cat and random stuff including cheese. Nope. No need for cheese. Nova! Hi. Welcome. Hi Freefall as well. What's under the desk, you ask? Everything. Also, hi, welcome, Fi! Hi! Oh my goodness, okay, the reverb's just one more time.
Now then, okay, I'm back. Oh my goodness, that looks so cool while it was coming out of that mode. What the hell? Look at this! Wow! This looks so cool! This should just be my avatar, what the hell? Especially with it all glowy. Hey! Oh my god, you can even see the Uno reverse card. Thank you for the pants, Chaos. Oh, I'm too close. Wow, look at that. Sheesh! Hi! Oh, it's one off now anyway. Hi! Hi, Gabriel. You have a weird tail, defies the laws of tail physics. Well, I'm sorry. What the hell? Listen how slow those rooms are. But Exia! Hi, welcome! Congrats on a full 2 years, because as we all know, 25 means 24 to Twitch.
Cheese.
Cheese.
See.
Hi, Beat. Why the cheese, though? This is not even the cheese taste testing stream, which will be, like, within a week now, because, in 6 days, it's my 3-year streaming anniversary thing. What? Wow. Wow. Okay, hi, you 50-50. That's really weird. That's really weird. She was starting to pronounce it just like the word cheese, even though she should have been reading each letter individually. Hi, well, it's because it's capitals. Hi, welcome. Yeah, no, the tail is fine. It's okay, you can make proper tails too. What do you mean make proper tails too? What do you mean make proper tails too? That's a fine tail. Anyway, Fox drew it nicely. I just tried to interpolate it, and I probably ruined it as a thing. Anyway, hi, Face of Trolls. Hi, welcome. Hi, Chaos. You 50-50. Belgium. Stew. Cheese. Luna. Yeah, the Elite Speak one works ironically because it converts it to lowercase. Have I caught up? I'm not sure I have. So many socials. You're so social and extroverted. Yeah, that's a great joke. Hi, Nova. Welcome. I got to your hi. I'm almost caught up now. And there we are. Hi, there we are. Azrael. I've fully caught up. Welcome. Now let me catch up on the redeems. We have a load of cheeses. Wait, how far back do I have to scroll? Hydration and posture check 8 minutes ago. Okay, 1 sec. I have to bend down for my onion juice now because, well, does this sound familiar to you? It shouldn't do, because I've never had a cardboard desk or a cardboard box on my desk. I've also never had a cardboard desk. Let me just hydrate quickly.
Chapter 3323. Cheese.
Oh yeah, those work. Hi, Chris. Welcome, welcome. Why am I so wide? Why is one my... Why are my eyes wide than the other one? Oh, I know why, because it's off-center. Anyway, hi, 1186 as well. Welcome, welcome. Posture check as well. Look at this Uno card in particular. Wink wonk. Why does this sound rude? Hi, Young Gear Jimbo. Welcome, welcome. Hi, everybody. I have a new outline for one that the animation AI makes. It's pretty smooth, actually, but I haven't finished it and would take all day to render. All day to render? Oh, you mean... Oh, right. The artist kind of render, right? I was thinking like a 3D model. Holy crap, like you wouldn't... I don't need that high quality a tail. But also I don't need that high quality a tail. To be drawn by you either, to be honest. I mean, the one you've drawn is perfectly fine. I'm not the one complaining about it in the first place. Anyway. Hi, welcome. Let me just continue catching up with redeems. Sorry, after that random outburst, let me get back to it. We have a from Freefall this minute, apparently. What the cat? I know, it's a weird one, isn't it? Hi, David. Welcome, welcome. Wait, that's the wrong way. Yeah, that one. That way. Hi! It took you all day to render the starting soon screen last time. It took me all day to render it? Wait, I'm not sure what you mean. It took me ages to make a flipping project out of it. But that's partially because flipping Shotcut, the video editing program I'm using, is goddamn crazily slow and inefficient. Getting it working. Yeah. Hi, Brighter Malphon. Does the funky little dance to piss me off? That has not pissed me off at all. In fact, thank you very much for the 60 bits. I'm sorry it doesn't show up extra specially on my overlay, but however, I do see it and I do appreciate it, and it is in the Twitch chat. So, welcome. You might be wondering why am I 2D? It's not because of my lights. And although it does seem that is on my face. Although it does seem that my webcam is. No, it's not. It's not a cheese webcam. It's just
cheese.
It's not cheese, David.
Cheese.
It's not. I swear. Thank you for the pats, Chris. Although the webcam. Oh fuck's sake. Although the webcam seems to be dying, it's not cheese. God damn it.
Cheese.
Sin. Cheese.
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 Oh. Cheese. No, it's not cheese. Printed cheese. What was I trying to say? Who fucking knows? Webcam probably is dying, but that's not the reason why I'm 2D. It's because webcam's going to be showing you something that I've never shown on stream before, but I've shown on my Discord, so it's fine. I mean, no, never before seen. Yes, absolutely, a debut. Thank you for the follow, Elias. Welcome. I hope I'm pronouncing it correctly. There is a cat on cheese. Wait, what? Cheese cam? maybe actually for the cheese stream. Yeah, you know what? This could be like a trial run for a hand cam, but not really hands. It's just a cam.
Cheese.
Wow, never seen it before. Wish I could have seen it like that the time I saw it in the Discord. Indeed. If you ever buy a house, I need to make sure that one whole side doesn't have grass, otherwise VTubers can't come visit. It's true. Not just because of the touching grass, which I guess was your joke. Also, welcome, Very. But also because hay fever! I'm not sure all VTubers have it, but I do, so. Anyway, what was I trying to do? Oh yeah, right. So, I'm gonna quickly show you some photos. Which are, but because, hey, surprise, spoilers, not really spoilers, but, big news! The, MIDI LED boards have been made, and they've arrived!
Fever, leave the uke alone.
Thank you, I get the reference. Zai has it too, allergic to pretty much all nature. I'm sorry, Zai. Sorry for you, Zai. Gloucester cheese. I'll see what I can do regarding sourcing things. However, spoiler! These boards will not work correctly because I made two very stupid mistakes. One of them much more stupid than the other. Well, I mean, they're both silly. One of them is more stupid, and critically, it's also more the reason why they can't work. So these were very expensive mistakes. And today's stream and the last few days have been me trying to minimize the wastage, actually make use of the boards, and actually use them as good tests and run tests on them so that I can find out things about them. So that next time, when I have enough money to do another run of the boards, but actually correctly this time, which won't be for a little while, because this was stupidly expensive. But anyway, next time, hopefully stuff will actually be correct.
Jeez.
And so far, they've passed a bunch of tests. Which I guess is just the bare minimum of making sure they're functioning, but anyway. Hi, Akinyanya! Welcome, welcome! Stupid mistakes and expensive mistakes are stupid, expensive. It's true, it's true! Hi, Hakun. Did you do anything with the sound clips? I still haven't done it yet! Wait, hang on, what do you mean sound clips? Are you meaning the modem sound one? No, I'm not gonna show that on stream. But if you're meaning the cheese sound, I absolutely should. I'm sorry, I keep forgetting. I'm sorry. By the way, if there's already consolation, you're not the first person I've done this to. I'm sorry. That makes it worse, I think. But it will eventually. The other one's made it in. If you don't want it in anymore, I can remove it. I'm sorry, but I will eventually remember to add it. Hang on, let me just turn on smoothing on this photo here before I show this on screen because I just noticed a bunch of aliasing. Hi and welcome. You can pat the 2D cat. You can. Thank you. I don't think they are stupid mistakes. I totally would have made those. I don't know. I'm going to show you just how stupid one of them is. Anyway, I'm hoping that I can get through this quickly and get to the unique part of the stream because it took me like an hour to set up, and that is also why this stream is a bit late and probably going to be short. I got the drain and source backwards on a septic, I don't know what septic is, oh, manufacturer, I guess, supply, because the symbol was silly and had them swapped. All the FETs are now upside down on their backs like helpless turtles. Hey, if you got it to work, you can extract the sound out of the modems and play on the stream. Really? Isn't it going to contain like a call sign information and some kind of personally identifiable stuff? Or is it just the raw file data? I always read that as you get a pat, and you get a pat, and you get a pat. But I understand that it's meant to be a reference to that woman who's not over here, but is apparently a big deal in America. Alright, I'm going to press a button and show you stuff. Because look, this is the first thing I saw when they arrived. Well, not quite. This is the first thing I saw after unrolling one or two turns of the bubble wrap. Boop! Look at this. Also, no, okay, that's interesting. How come? Look! This is it! This is it! It's actually here! Look! This is it in the flesh! Look at this amazing ray-traced render of this board. It's done by my camera. How cool is that? Look down there. You see flashy lights. Ironically, this uke will never see flashy lights. This long uke. It's sad, but she'll never see flashy lights. Cabbage said that she's seeing it due to low blood sugar level because there are not actually going to be any flashy lights. By the way, fun fact, this is actually the direction that the photo came out because I was an idiot. I had to rotate it that way in software. Anyway. On the next screen. Look at that! Look! Look! Oh, this is after I soldered some stuff. Wait, why is this out of order? Hold on a second. Hang on a second. Why is this out of order? Wait, is it out of order? Yeah, it is. What the fuck? Okay, anyway, the other side. Look how beautifully made this is. This is assembled by GLCP2B, hashtag not sponsored. Microsoft mouse here for size reference. This is like very small stuff that I wouldn't want to do by hand. Yeah. This shiny long nuke is copied, totally just copy and pasted from my other board. The previous one. But this looks so flipping cool now. I wish I didn't have to have all these C63, C64, all this little text visible, even though this is like half cut off. They can still read it on the Gerber files. Or Gerber. I don't actually know how you pronounce it. If it was German, surely it'd be Gerber. Look at this $300 cup holder. Yep. Yep. You're. Yeah. It's. Yes. I didn't want to say the exact amount, but it's somewhere around there. Anyway, so what is this board for? Something you design? Yeah. This is a thing I've been working on for the last couple of months. In fact, let's bring it up in the design. Hi, Bryce Mouth. Wait, I already said hi. Sorry. I'm looking at. Wait, I need to shut up and actually do one thing at a time. Where the fuck's the board? Here it is. So yeah, this is it. Hi Omni. Omni.
Cheese.
Look, it's not catching. Oh shit, it caught me. God damn it. Hi Omni, welcome. Yeah, I've been designing this. This design that you see right here is very subtly, very subtly changed to make it work. So it's not quite the design that you see here. I mean, it looks identical from the outside. Take a close look at that cheese and the shadow of that cheese. Anyway, yeah, it's so cool to see this in real life. Anyway, next photo. Wait, what is the next photo? This one, I guess? Yes, this one. Here's an up close and personal shot just to show you some of the details of like the positioning of things and stuff and blah blah blah. And hi Delphin, welcome. Hi Soup Haven, welcome. I did, but it won't work as expected. Spoiler again. Well, actually, you know what? I'm gonna stop spoiling. Anyway, here it was after I soldered on these things, these power connectors. I was obviously not gonna solder on every goddamn LED first. I was just gonna just solder the bare minimum to be able to test things, and I'm glad I did. Here's the other side. And yeah. Okay, so here's the problem. $3,000 chopping board. Okay, wait, didn't waste that much money. I don't have that much money to be wasting. But okay. Shadow of the cheese losses. Oh yeah, shadow of the cheese on my face. Yes. So here's the problem. Here's the problem after some debugging which is also done in a Discord voice channel, although Nova's one, I think, or not mine. No, I think this one wasn't mine actually. I think this was him in one of my voice channels on my Discord. Remember Sandbox being there. Anyway, here's the problem. Apparently I can't read 4 letters in large bold text at the very top of a datasheet. The very top. Well, not literally the very top, but the very first page of the datasheet. So, Doohoo! Hi! Hold on. I'm trying to find the datasheet. One sec, where is it? Shift register. Here it is. Oh, you keep on adding a 0 every time. What is this? Here's the problem. If they make it the first thing you read, they make it the first thing you forget. Yeah, true. Here's the problem though. Wait. I've lost it. I've scrolled in too far. What? Zoomed in. There we are. Wait. I think I need it slightly bigger just to be able to make sure I read it correctly this time, because I didn't read it before. Here it is. Here it is. Here's the word that is the reason why this doesn't work. So, what that means is that the so-called outputs of the shift register, which are still confusingly called outputs, they're not really outputs as you'd imagine. Whereas you'd expect this to be like providing a positive thingy, and then all the other sides connect down to ground. Well, no. What they actually do is they allow current to flow into them. They sink the current, they don't source it. So it's not even as simple as swapping around the LED, because on the other side of the LED, in my schematic, was ground, right? Out, down to ground. But what it actually needs to be is 5 volts on this side, down into out. Yes, into out. Into out! So outputs just for electron holes, not electron. Okay, yeah, sure. Sure. True. Hi, Pika. Hi, Finyuki. Welcome, welcome. That gave me the deja vu or PTSD from my electromechanics classes. I'm sorry. Let that sink in. Sorry, that's funny. $3 million Lego foot trap pane? Oh, yeah. I was about to say the board is actually pretty flat and wouldn't hurt that much if you stepped on it. But yeah, if you step on these little bits, no, that's gonna hurt. But bottom line, don't step on them, please. With a bunch of lines cut, you might make it work. Well, the problem is the way they connect to ground is through this, an internal ground plane. Look, they're not connecting anymore because I've already fixed it. Here's the 5-volt plane. They are connecting to this now, so I've already fixed this. However, I was able to bodge things together enough to see if the rest of the circuitry worked. And that's when I noticed my second mistake. Well, actually, I noticed the second mistake first. The second mistake I'm telling you is the one I noticed first, which is on the back. Screw it, I've got photos. I'm going to show you the damn things. These little things here. Let's rotate this. Rotate. These little things here. So these terminals let in the logic signals from the Arduino that control the board, not the power. The power comes in there and on the other side of the board as well. But the power goes through these little things to clean up the signals first, because obviously, you know, this is the real world. Everything's analog. Nothing's nice and clean. And long wires come in here, so it's, you know, to clean it up into like a nice sharper. Either the voltage is nice and high or the voltage is nice and low and not any weird wiggly in between noisy thing. I cheese, exactly. Hi Myriad, welcome. Just need to cut 4 trace of each LED. 4 trace of each LED. The problem is, it connects inside the board. I'll show you in a minute, Luna. So I run through these things, which are called Schmidt triggers, which are the things I've talked about before, where like, when it drops below a threshold, cheese happens. Hi, Freefall. They pull down instead of up. They pull down instead of up. Yeah, you could compare it to that. Yeah.
Cheese.
No, this is a full air board. Why cheese? Hi, Howdy Dev. So I run it through these Schmidt triggers, which are basically when the voltage gets below some threshold. I don't know what the exact threshold is. Say like 20% or something. I'm not sure. I'll have to check the data sheet. But when it gets below some data sheet, 25%, it treats that as properly a low signal. Thank you for the follow installer. Welcome, welcome. And when it gets above, let's say 80%, it suddenly goes up to high. So anywhere between the 20 and 80%, like if the signal is noisy there, it's not going to rapidly switch between them. That's the idea of how these can like clean up the signal. Problem is, I didn't realize, and this one actually was a little more hidden, just like slightly more hidden in the datasheet, just a little bit. It wasn't an enormous word at the top of the datasheet this time. They're inverting Schmidt triggers. When the voltage goes above a threshold, the output goes down to ground, and when the input goes below a threshold, the output goes up to the voltage supply. However, that's not a deal breaker. That's not a deal breaker. I can just completely invert all of the outputs on the Arduino. So that's not a deal breaker. It's stupid, but it's not a deal breaker. It does prevent the boards being able to be chained together though, because that's how I was going to be able to connect multiple ones of these boards. The signals were going to go in, get cleaned up, come out here. And yeah, then on the next board, obviously it's the same board again, so they go through these again. Problem is, if these are inverting, the first board inverts them, and the second board inverts them back, and the third board inverts them back again, and the fourth board inverts them back again. So every odd-numbered board would work, and every even-numbered board would get the signals flipped around. So that's a fun thing. But that still might have worked if I just connect all of the inputs from the Arduino directly. It might... The capacitance of the lines might not be too high. Just multiply by -1 in every even board. Yeah, that's the problem is that's basically what they're doing, kind of. kind of. Or more like it's doing VCC minus the thing, right? So if this is a MIDI board, does this output all the notes until you press keyboard keys or something? It's just an LED display, basically. Well, it's actually just a paperweight, but it's supposed to be an LED display that shows you all of the parameters for all of the channels. So things like volume expression, but also like attack, decay, release, cutoff and resonance for the filter, number of playing notes, the pan position, instrument number, and that's all I can remember off the top of my head. I have checked and it seems to be safe from a previous issue. Okay, nice. Thanks, Hakan. And thank you for the like as well. I think it's 80-20 for a Seymour Schmidt buffer. Oh, okay, I just plucked those numbers out of my anus, but nice. I'm sorry for the joke, don't feel too bad. Wait, what joke? I don't feel bad. Oh, $3 something hard to get spare component part holder. Yeah, true, I did have to pre-order some of these parts as well. As if anyone can afford to step on boards in this economy. True! Can you send it back for the right output chips? I cannot. They're not going to desolder stuff, unfortunately. By the way, the problem is there are no. I couldn't find any other chips of the same size, QSUP24, with like the same pinouts or anything, or even just another thing of the same size at all that is even stocked that does this job. So I'm gonna need to remake the board. Like I can't desolder these myself. I don't have the equipment needed to desolder. It's been sitting on throne for a while, but I don't have it. But even if I did, I wouldn't have anything to replace them with. It's not these things' faults. It's the board's fault. Is this like something that's been censored? Oh no. Hi Nick Fluentes. If you put something, Twitch thought it was a link and it got censored. I'm afraid. Thank you for the pants. Hi Ascento. Good evening. Sounds like unique Uke merch. Own your own part of Uke R&D history. I mean, that's true, actually. Thank you for the hydration and posture check. I'll do that now. Wally, look at this beautiful black screen. I do love how they look, Hakan. It's a shame they can't be used for much. However, they can be used for something. Let me posture check as well. The amount of money I'd have to sell them for to even break even would be absurd, and absolutely nobody would want to buy one. This is also why I could never like commercially sell these because it's so niche. And I know now how to make them less expensively, but the problem is that would require a big redesign. And I kind of think that I'd rather stick with what I have because I have like the actual board like made up in front of me that I can do real tests on. And I can just fix the problems I see on there and then order it again and be much more confident that it'll work. Whereas the alternative is if I try to redesign the whole damn thing to make it cheaper, then you know, great. But I'll probably end up needing to order two again because I'll probably make some big mistake again and it like won't end up cheaper in the end. Do you know what I mean? This is like, this is halfway between sunk cost fallacy and like actually probably really being cheaper. Anyway, let me show you the datasheet for the other one. Yeah, maybe making it like it would be a better design if I make it the cheaper way. This is a silly way of doing it, but just this component is obscenely expensive for a component that's, you know, gonna be 132 of them on one board. Anyway, let me show you the Schmidt. Where are we? Buffer, blah 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 blah. Okay, so this is what I had in the end. Look, it doesn't sit. Oh, it does. Wait, hang on, this is the wrong datasheet. One sec. Where is it? One sec. Oh, I've written this already. I can't see the. Hang on. Which part was it? I got a folder of a bunch of datasheets, and I'm trying to. I think it was this one. I think it was this one even. So never mind. It does say inverter at the top. The symbol. These? It does have the not circle, yeah. But if only I'd scroll down to this very easy to understand table. Input low, output high. Input high, output low. Yay! Anyway, so if anybody was still under the delusion that I'm actually clever and big brain and stuff, you know, please stand corrected. Please stand corrected. Yes, so this is what we have. Output voltage is equal to the active mode or power down mode? What is power down mode? Oh, when the voltage is 0. Okay. Supply voltage. So it outputs... how could it possibly output higher than VCC? Apparently... Oh, okay, whatever. I guess they have to give margins of error, but how it could possibly output half... Okay, whatever. Anyway. You get big brain, you can't counter my delusion. Well, unfortunately, I don't have anything better that I could counter it with. Smarter than you? I'm not sure I'm smarter than anyone right now. Yukia, I don't suppose you can make a little daughter board that would connect to the pins on that register and allow you to salvage and test with these boards. Well, I already have been able to salvage some of... Well, I've got stuff working because look, next... Thank you for the pads, Stu. Next photos... I have, in a very scuffed way, been able to connect up a bunch of LEDs. So what I did was, I soldered everything that was to the, quote, output of the shift register, and I cut the lead that was going to go down to ground. And then, holy yuck! And then I joined all of these short leads that need to go to 5 volts together, like this, in like a grid like this. So they're all connected together. And then this wire goes off down to a nearby 5 volt supply that was meant to be having a capacitor there. So, and this does work. This works, which is really, really cool. Slight spoiler. And so yeah, that's really, really nice. It does actually work. And then I whipped up this little test program, which is no longer running for some... Oh, it is. It's all the way up there. So yeah, all inputs of the board are inverted, so I called active low and inactive high. I worked in a company that was making a smart street park meter, and they spent more than a year having problems with the radio until they found out they were feeding 4.2 to the radio and not 3.3. Oh my god, the volts, oh no. Oh no. How did they manage 4.2? Where does that come from? You have $283 of PCB boards coming in the post, most likely this week. Hey, you and me both. Well, yeah, it was this week. Technically it was this week. This is Sunday. I wish I could say it was only $283. I hope it works though. I hope it works. At least you have someone to like blame other than yourself if it doesn't work. Hi, F. Paul. Welcome. Imperial Vaults! And then you shone bright like an idiot. Thank you very much. Hi, F-Paul. Thank you for the pants. Okay, so this is a very rough thingy. Originally, I was using this code, where I just turned on the data to be active, and then clocked in 16 bits. And this little function... oh, it's still here, actually. Just turns on a pin and then turns off a pin. And I was doing this with a delay of 1 millisecond, which is so slow. That's like a 500 hertz clocking the speed then, which is like nothing. 500 bits per second. Just because I wanted to see if it worked, right? If it doesn't work with this, it's not going to work with anything higher, you know? Anyway, and that worked. And then I tried some other things, and it's worked with everything I've ever tried, including 4 megahertz. 4 megahertz clocking speed, which I'm so happy with. That's I was hoping that I'd be able to get that out of it. And In fact, it even worked with 8 megahertz, which is the highest the Arduino can do. But by that point, the waveform is looking just a little bit not so clean anymore. So, like, I'm probably going to stick with 4 megahertz. This is on Arduino. It's an Atmel 2560. Arduino Mega. Hi, Yuisha. Welcome. Because someone had the great idea of feeding the radio from the battery charger output instead of the 3.3 volt. Ah, I see. Let's fix everything easy. When we mess up, we can just edit the code and wait 5 seconds for it to recompile. True. Okay. Hey, would you like to see something cool? Good, because you're gonna. Let me just change something. Actually, I'm gonna put this back to where it was. I'm gonna slow it down slightly. I'm just gonna upload this to the Arduino. Let's make sure this works. I'm gonna select the correct Arduino, which is this one. If I select a different one, then I'm gonna overwrite the code that's running that allows me to have the temperature on my wall over there. So I don't want to overwrite that Arduino's code. But let's hope this is the correct one. Boop. I'm sure it is. Unless it's suddenly changed COM port number since yesterday. Yeah, it's correct. Okay, it's uploaded. Now I'm gonna plug in the power to make sure this is still working. I mean, it kind of is. Hold on. Oh. Maybe it's not. Oh, it is. It's just extremely... Why is it... Hang on, why is it going so quickly? Why is it going so quickly? What have I done wrong here? Anyway, I want to actually show you something. So there's the thing I can press on OBS. It's going to do something I've never done on stream before. Are you ready for it? 3, 2, 1, boop! Ta-da! Look! It's a live view! This is the camera! Ah! And it's the LEDs are looking flickery because they're switching on and off extremely quickly, which is this is not like an artifact of how they need to be driven. It's just an artifact of how I am turning on one LED at a time, and then the next LED, and then the next LED. And I was originally doing this at 20 frames per second, and now I'm trying to do it at 10 frames per second. But for some reason, it's being really fast still. I'm not sure why. It doesn't seem to have slowed down. I'm probably making a really obvious mistake somewhere. Was this commented out originally? Yeah, it was. So why is it not changed? Am I doing something? What am I doing? That's the reason why it's not being slow. This is the code that was yesterday. Let me upload. You'll see only one LED stay on while it's uploading. There we are. Why is it still going so quickly? Wait, what? Why is it still going so quickly? Welcome back, Luna. Why is it still going so quickly? What the fuck? So what it's meant to be doing is, I have this variable here. Let me walk you through the code. I have a variable here. This is a 16-bit integer. And it starts off at 0. So if it's 0, in other words, if no bits are set, then it's going to become 1, a value of 1. That is, the rightmost bit turns on. Then we transfer that out over SPI. That is the data and clock lines, which are running at 4 megahertz. And we pass the inverted version of this because, remember, I'm using the Schmidt triggers, which are inverting every goddamn thing. So all the zeros will become 1s and all the 1s will become 0s. And then we pulse the latch pin, which I'm still doing in a very naive way, just with digital writes. Oh, wait a minute, we don't need that anymore. I was doing 2 of those pulses just so that I could show how slow digital writes were on the scope. Spoiler, it's extremely slow. Oh, I know why it is! Because I flipping disabled interrupts! which are necessary for the delays. Right. There we are. Oh. Okay. There we are. So now the LEDs are going one by one. And then there's also one state at the very end where they turn off. Anyway, after the after one is clocked out, this is no longer false, so it'll do this branch instead, which is just to shift the one bit one step to the left, one step to the left, one step to the left until it gets shifted out of the most significant bit and it becomes 0 again. And then it's gonna restart. But this is only gonna reset this after one full loop of 0 having gone through, which is why after all 16 LEDs have turned on, there's like one frame where all the LEDs are off because we've clocked out a 0. Actually, we've clocked out a 65,535, which is everything on. And then that gets flipped by the Shimmy triggers. It's so cool we can see the code in the app at the same time. Hell yeah, you know what's even cooler? Would be if we could actually probe the data that's being sent using a scope. Wouldn't that be cool? Wouldn't that be cool? Let's do it. I'm gonna do it. Hi C, welcome. By the way, I just want to emphasize that not only is this proving that the shift register itself is working, but it's proving that the... I've got to move this keyboard out of the way. It's proving that the... Whee! Oh god. It's proving that the... all this stuff over here, this information, this address decoding thing basically, that is deciding where to send the latch pulse to, which shift register, that is working as well. Because this register that's controlling these LEDs, and only this register, is doing things, which is extremely nice. So in other words, the data is getting to the correct shift register on the correct channel. I've only tested this so far with the top channel, so channel 0. Basically, let's just call it X and Y. Cheese. I've only tested it so far with a Y of 0 and an X of 0, and also an X of 1. So basically, the top 2 shift registers that are side by side. And this one down here on channel 1, which is the third shift register along. And that works. But what I'd like to do today is write a piece of code that's thoroughly going to test every single one of those, and I can probe every single one and make sure that only that one is responding. And I've come up with an idea of how to do this. Welcome in the 0x539. Hi, why cheese? Code, camera, and probe. Careful with scope creep. This is a sustainable recycled... Look, it made me laugh the first time. Okay, let me just set up the probe to... Let's see. Oh god, I keep accidentally slightly touching my headphone cable and it just goes onto only one ear because the plug is shit. Okay, if I'm probing here... Alright, we see a thing. Which is running at the not particularly high or stable frame rate. I was doing this on Discord last night and it was so smooth, the web interface for the scope, which is what's being shown there in the top right. But yeah, for some reason while streaming, it is just not a great frame rate. Oh, I've lost the wire. Hold on. There it is. But yeah, I think everybody who was in the channel can confirm that it was smooth, much faster. I was doing this in Nova's channel, I think, actually, Nova's server. And for some reason it's not. Same network usage? No, network usage is going to be higher, I'm sure. I mean, like, for everything? I mean, I'm streaming now, so I'm sending much more. 6 megabits per second, or 5.5. 6, 5.5. For download, it's showing up as 3. I don't know what it was before. 6, I think it was before, right? And yeah, it was smooth even on OBS's thingy. It was 3.5 or 4? Oh, okay. Packet priority maybe. I'm guessing that must be it, right? The quality of service thingy. Anyway, what you're seeing here when I probe this is the data pin, and it's just one little pulse by itself. Let me reset this position. I'll just keep it running constantly. 8 when you had it open twice. Oh, okay, I thought it was 6 and 12, I misremembered. Which one? Oh yeah, clock. Okay, hold on. I'm trying to now probe. Hang on, let me move my mic so you can actually hear if I move over here. I don't need to worry about my 3D tracking going weird. Because the webcam for my 3D tracking is pointing down at my desk right now. Well, this might be tricky to do. Okay, there we are. Do you see that? Oh, it's off screen a bit. What the hell? It's almost like I had it positioned to the left for a reason. So these are this is the 16-bit integer being clocked in. You can actually see there's a bit of a delay with the Arduino's processor between it clocking each half of the 8-bit thing, which is pretty fun to be able to see it. PNG because handcam? Yep. The camera that I use for that is the camera that is delivering your bottom right view. By the way, is that clearly visible? Do I have the gamma turned up on that source? I remember needing to have the gamma turned up on it because it was dark. Oh, it's not! Oh, hang on, let me do a thing quickly. I'm gonna do a thing that should make this easier to see. There we are. That's a bit more like it. Have a nice luck, folks. And now if I probe the data on the yellow line, look at that! Oh, it's actually smooth enough to be able to see it. How cool is that? Why are you spraying me? Look at that! Look! You can see the bit, like, being clocked in. Firstly, it's the least significant bit, and then it's the next bit number 1, bit number 2, bit number 3, bit number 4, all the way up to bit 15, and you can even see it disappear off the end. How cool is that? Hi Liquid Cake. Is there repairing in progress? Nah, not repairing really. I'm just probing and making sure that it kind of works. So since this works, what I'm thinking of doing is I want to program it so that it can what I want to do is program the Arduino to address the like X0, Y0, the very top right from your point of view. Chief Trainer? Doing MIDI stuff too? Nice! Hi Raymarch, welcome. I'm not really doing MIDI stuff at all, to be honest. Wait, hang on a second. Have I just accidentally turned up the... Oh my god, I'm such an idiot. I've turned up... Oh, okay, hold on. I've turned up... I put the gamma on the wrong flipping thing. Hold on. I meant to put gamma... Oh god, a hiccup. I meant to put gamma on... Oh, there already is gamma on. How did it look without the gamma? Oh. Not wildly different, to be honest. A little bit different. Alright, we'll do that. Sorry, I didn't realize I was turning up the gamma of the webcam as well. I thought I was only turning up the gamma of the oscilloscope view. Am I living in a lab? I'm not. My desk is an absolute mess. Would this be salvageable with little boards to put the LEDs on? They're connected to one of the pins below, but not the other. Yes. Yeah, it would, actually. That is a thing that could be done. But, yeah, that is a thing that could be done. I have to solder so many pin headers. Holy crap. Why not a matrix of LEDs instead of one LED per pin? Because I'm stupid? You're massively overestimating my abilities. I assume it's only one LED lighting I'm scattering into the other ones. Yes, yeah it is. I can turn down the exposure a bit. Does that help you see? Yeah, there you go. Now you can see. Can't really see the board though, but Is this sync to the music? No, absolutely not. It's just 10 FPS. So what I want to do is make the Arduino address X0, Y0, and then hi some mic, and then a rave board. Adjust the gamma in the other direction. It's I can't. The problem is it's blowing out before it reaches the computer. I mean I can obviously, but it's not going to help. Let me show you. That's extreme gamma in the other direction. Help! I'm stuck. Where's my mouse? There it is. Thank you very much for the follow. Not a fairy Yif lover. You're the second. There's a mutual regular friend by the name of Yifweed here as well. I feel like you might get along. Anyway, welcome. What am I trying to say? Oh yeah. Right, so I want to make a thing. I want to make the Arduino address the X0, Y0, and then like turn on, just pulse all LEDs on and off for a moment, and then address the like X1, and then X2, and then X3, all the way over to X7, and then drop down to Y1, and then go X0 to 7, and then Y2, X0 to 7, and then Y3, X0 to 7, and that covers all of the main shift registers. And then there's an additional 2 right at the very far end. I can actually just move the camera and you can see them, which is difficult because my keyboard's in the way. Well, this is actually quite hard to... These 2. This one and this one. Those 2. This one. There, I don't know if you saw the Probema one. Yeah. And there's the long nuke as well. Gotta have a long nuke. Oh God. Help! There's not enough space for everything. Ah! She says punching the mic by mistake because there's not enough space. Okay. And I wanted to do that like in a loop. So first X0, Y0, then X1, Y0, X2, and I wanted to do that the entire thing in a loop. And what I want to do is move my probes from what would I do? I think I'd use 3 probes then. I would make the Arduino just pulse some dedicated line, like not any of the ones that I'm using currently connected to this board, but another one. And it would do that at the beginning of the loop. And I can use it as like the trigger that the oscilloscope synchronizes on. So the start of our capture, if you like, happens when that pin pulses. And that serves as like a reference for when the Arduino is going to be doing this stuff. Like when it's going to be doing X0, Y0. Like X0, Y0 will immediately follow that pulse, for example. And then I can basically just probe one of the outputs on the X0, Y0 shift register. And we'll see if that is the one that does its thing immediately after the pulse and like no other time until the next pulse. And then I could like, while keeping that probe on X0, Y0, I could move the probe over to X1, Y0, and we'll see if that one happens immediately after the previous one. And if I just keep on doing this, working my way along, eventually I'll have covered every shift register and it will have activated immediately after the previous one to show that the addressing is working correctly. Thank you for the follow very much. And yeah. And then hopefully each and every shift register turns on at only one moment throughout that cycle and in the correct order. Ah, no worries. I appreciate it. Cat finger spotted. It is long and has a metal point on the end. Shush. I'm self-conscious about that. Jeez, I'm self-conscious about my tail now as well. I mean, tail already. Now a finger as well. Nested loops? Yeah, I guess we could. We don't have to do it that way. It probably would be easier to do it that way though. So yeah, that's my plan. And then also I'd need to check the 2 message ones at the very end. So yeah, I think it's about time I write code to do that. Really shouldn't be too hard. The hardest part is going to be converting the like the X index into these 3 pins, because right now I'm just using digital pins that are next to each other on the Arduino. And unfortunately, these digital pins are not necessarily next to each other on a port on the Arduino. I've gone through this in the past, but essentially on a microcontroller, the way you control I/O is through ports rather than pins. And it's the wrong text file. It's the right text file. I actually did this on stream before, but I worked out, here's port A, for example. A corresponds to these digital output pins on the Arduino. So actually, let's have a look. I'm using 10, 9, and 8 for X. And pin 10 is bit 4 of port B. Pins 9 and 8 are actually on a completely separate port. So eventually I want to move these all onto one port, so I don't need to use digital write at all. I want to, you know, it's so much faster just being able to write out to a port, 8 bits at a time. Even if you only want to change 1 bit, it's faster than relying on digital write, which has to work out which port and which bit of the port it should be. Anyway, one day you need to follow the way of platform I/O. Maybe. Was that your tail wrapped around my finger? Shush. Using port also is nice to do math. Yeah, exactly, because you could just spell out the number 0, 1, 2, 3, 4, 5, 6, or 7 on 3 bits, and then just shove them along into the correct position on the port, and write out to the port. And bam, you've just written a binary number without even needing to break it down into binary. You've just sent a binary number over a port, basically. And then your circuit decodes it, which is the cool thing. But, you know, these boards are... That's for the future. That's for the future. Anyway, so let's do that, I guess. I'll just have to work out a way to do this that's not beautiful like that. Okay, beautiful might be stretching it. Graceful. And I got to do that with this keyboard sitting on top of this box, or I could just move the box, I guess. You can't see anything right now, so it's fine. Okay. Also, one more thing about these LEDs. They run a little warm, which I wasn't expecting. I'm powering them with 13 milliamps, which I verified with my multimeter that it actually is 13 milliamps. So the shift registers are doing exactly what they should be doing. They're constant current shift registers, and they are providing 13 milliamps. So but the yellow LEDs and the green LEDs are much dimmer than the red ones at the same current. This is also according to the datasheets. They are just less bright LEDs because of how they work. And so what I'm thinking of doing is maybe lowering it to 10 milliamps, and then basically, I'm wondering if I can write code that will turn on all LEDs that should be on, and then immediately turn off any LED that's red, while keeping on every other LED. So the effect will be that the red LEDs run at a very small duty cycle, very low duty cycle, and then green and yellow just stay on because they're darker and we need them the extra brightness. Yeah, 13 milliamps. I didn't think that was outlandish. I thought it was sort of typically assumed that LEDs would run at like 18 or 20 milliamps, but I certainly wouldn't want to run these at that. I mean, the datasheet shows stuff up to that, but you can use a constant current source. You can get 3-pin. These shift registers are constant current shift registers. That's the main reason why I ended up using them. So yeah, but the only thing is, if I do that way, then I essentially am having to flipping like scan all of the. I'm basically having to repeatedly send things out over and over and over and over. Constant current sinks, true, not constant current sources. Constant current sinks, that's the problem. But yeah, if I do that, then my Arduino is going to have to keep on over and over and over and over, like all the time, and whatever the frame rate is, I guess, be turning on and off and on and off and on and off things. And I was kind of hoping with the design of this circuit that wouldn't be necessary. I could only update the things that have changed. But, you know. I guess if it's fast enough, it doesn't really matter. I was hoping to be able to avoid scanning and stuff, but for the sake of not being blinded by the red LEDs, I might do that. Because it's a constant current for every output of the shift register, which is really an input. And some shift registers are controlling different colored LEDs. It's not like there's only one, you know, otherwise I could just make the shift register that's driving the red ones be lower current, but there's mixed red, yellow, and green across the same shift register. Does shift register have a change pin? A change pin? I don't know what that means. Like a latch pin? Something to make it change the outputs? Hi Dara, welcome, welcome. Yeah, it does. Oh! I think I know what you're gonna say. Although, no, maybe I don't. Never mind. I am not too bad, thanks, Dara. Wait. I actually can do this. Yes. Wait, no, I can't. Shit. No, never mind. Sorry, I was trying to second guess what you were gonna say, but I can't. How's Yuki? I'm not too bad, thank you. I just hiccuped, but it was weirdly silent. It was just a tiny click and then it got blocked. Hope the Dara's okay. Hi Lane, welcome. You answered twice the same answer. I'm not too bad, thanks, Dara. How's the Dara? Yeah, so what I was thinking was I could just output a click up? Oh my god, nice. I was thinking of, you know, I just like turn on the LEDs that I need, all of them, regardless of color, and then after a moment I sort of turn off. I like output data that will turn off the red LEDs and then address every shift register and just latch those ones that contain red LEDs. But rather than having to clock out data and latch for every shift register. But that's not that's not possible because they're sharing like maybe some other pins on the shift register which are controlling yellow ones should stay on, so I can't rely on every shift register needing the same data, because maybe channel 1 has some yellow LEDs on, but channel 2 should have them off. And so I don't want like to turn off all yellow LEDs or to make all yellow LEDs turn on. I will need to check. Also, a big annoyance. This is going to mean that I need to keep track of more things. Some shift registers... actually, no, you know what, no. It's probably fine, I'm getting too ahead of myself. Let me just do this test, okay? I've been talking about this for ages. Let's just do this test. Alright, loop sequence. This is not a thing we're gonna do anymore. Get out of here. What are we gonna do instead? We're gonna do a thing that's called test all shift registers. Test all SRs. If you have megahertz, you can keep doing it. It's true, but if I remove the delays, then there's actually still is a delay between things happening, you know? Like, it's only a 16 megahertz CPU. So obviously I'm going to try to do things efficiently. Like, this is one of the reasons why I like using an Arduino. It's fun. Like, it's very rewarding when you make the effort to make your code more efficient. And you can really see the difference. but if you can get a microcontroller with DMA, you can do that without any problem. Really? I'm sharing the clock and data across all shift registers, if that helps, and then I'm just directing only the latch. I think I've probably absorbed what's wrong with the boards now and why it's non-trivial to repair. Ah! Yeah, hi BrainZap, welcome. Almost didn't see you there. Sorry, unless I already said hi, which I might have done because apparently my memory's crap. Anyway, test all blah 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 blah. Okay. What am I trying to do? I was not originally thinking of doing this, but I guess I will? Let's do it this way. Let's call it, what should I call it? Y. Index Y. This can be a uint8t. I need to make a simplified version of my standard uke lib. Or uke standard, uke STD, right? That was it, uke sexually transmitted disease. So that I can just get away with typing u8 instead of uint8_t. Or I can just define it at the top, I guess, but anyway. Int y equals 0, and y less than or equal to 3, or just less than 4, I guess, no. The shift register isn't chained? Nope. I don't want to have to output. See, this is why I was hoping to not have to output everything. I mean, I thought it would be nice if I didn't have to output an enormous chain only when I wanted to update one thing. And if I only wanted to do this without turning on and off everything all the time, that would be really nice. I could just update one shift register when necessary. When I receive a MIDI message, the relevant shift register will get updated. Without needing to clock out, 2000.
Kids. Why the uke? Kids are the uke. You kids are. Uke's so cute.
No, you. You sure? But yeah, otherwise I'd have to clock out around 2000 bits whenever I wanted to update a single bit, which I kind of didn't want to do. But if I haven't to update them all the time, then blah 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 blah. Warning, Arduino is a weird version of C++11. They didn't implement everything of the version. Who are you warning? It's fine. This ain't my first rodeo, as they say. However, they actually implement more that I wished was standard that even isn't. Because when I learned C originally for the Arduino. And so I was able to do something like this. Say, I think that was the syntax. It's been a while since I've done it. But this is like a range. And this will match anything from, say, 1 to 8. So it'll match 1, 2, 3, 4, 5, 6, 7, or 8. And this is not standard. This is a GCC extension, and I didn't realize that. And I was so annoyed when I went to use C in Visual Studio with the MSVC compiler, because it doesn't support ranges. Like, why is that not standard? That seems crazy to me. Anyway, we now return you to your regularly scheduled uke actually doing things instead of ranting. But to be honest, I think the rants are much more regularly scheduled. Alright, so inside we want to do index equals 0 and semicolon.
Nanya says the uke.
I did! Wait, did I actually say it? I said blah blah blah, I think. I've seen a long uke, but this is a nyahing uke. I nyah a bunch. I've been known to nyah every now and then, There's the odd nyah. Very odd, because I'm the one doing them. I lost so many hours until I found out that I think was dynamic that isn't implemented. I can't type a sentence! Pat, it's okay. They get you hooked and then taken away. Ah! I know, right? Alright, so we want to, when the Y is changed is the only time that we need to update the Y address pins. So I might as well just do it here on the outer loop. Thank you for the puzzle check. I can't believe I'm meant to be stopping streaming now. but I'm not going to. So I'm gonna sleep in a disgusting state and then shower tomorrow instead. I wanted to shower this evening, but I haven't done anything on stream yet, so I want to actually get something done. Dynamic cast. I don't even know what that is, to be honest. Wait, that was shit. Let me try again. Never mind, it's basically the same. Hopefully you can get use out of one of those, Nyanzaline. A stupid bug blowing my nose in my bed. Aww. Pat. NyQuil. What is NyQuil? I know Nyquist. RTTI and exceptions are usually the things people turn off. What is RTTI? Double Nyans? It's a cast that does sanity checks. Oh no, at runtime? I don't think you'd want that on a microcontroller. Sheesh. At least, you know, not one with as limited as this. Casting a pointer to a superclass, subclass, inheritance stuff. Ha. Yeah, I generally just treat this as C. The only time that in the past that I've treated it as C++ is when I used the new keyword, which I did for one single project on an Arduino before I understood malloc. But now it's like malloc, my beloved. I don't wanna. I'd rather use new. I'd rather use malloc and free rather than new and delete. Anyway, Calpol? Oh, okay. Well, I wonder. Calpol is paracetamol. At least it was when I was a child. Maybe it's not anymore. Maybe there's extra stuff in it. I don't know. Yeah, Calpol's delicious. Anyway. New and delete are kind of over. Alright, let's do this. So, based on int y, we want to turn on pins 5 and 6. Oh, I don't care, the pin y0 and pin y1. Alright, so, this is disgusting. We're going to be using digital write. Oh, actually, you know what? This is actually a case where how slow digital write is might be a pain in the rectum when I'm trying to look at it on my scope 128 steps later. Because there's 128 shift. Oh no, there's only 32 on one board. Never mind, there's only 32. Okay, whatever, I'll use digital write. I was considering for a moment writing to a port. Which pins are... Oh, which ports are pins 6 and 5 on? Ah, well, 6 is 1 and 5 is something else, so whatever. Bang goes at it. My X's and my Y's are spread across all different ports. Okay, so pin Y0, we're gonna output as whatever the bit 0 in this is. So it's this ended with 1. Or I guess we can just type it this way actually. Or 0, 1, sorry. And the other one will be 1, 0. I think it's more intuitive. But we kind of want it flipped, and actually to make it work either way, I'm gonna do this way. We're gonna say if this is the case, then we output, what do I call it? Active, else inactive, and this might be more work for the CPU than I should be doing, but whatever. Anyway, that's Y, and for the X, we're gonna do almost the same, except it's going to be x0, x1, and x2. And we're going to be looking at int x, and it's going to be 001, 010, and 100. Okay, now we want to turn on and off all LEDs. So we're going to transfer 16-bit, because there's 16-bit shift registers. It might actually be faster to do, I wonder if it's faster to do 2 8-bit ones rather than one 16-bit one. It might actually be. Well, you know what? I've got a fucking scope here. I can test it. I have the power to test it. But for now, due to laziness, we're gonna output 0, which is turning on all LEDs. And then we're gonna pulse the latch, and immediately we're gonna turn them all off again. But don't worry, the pulsing, because it's digital, right, is so goddamn slow that we'll easily be able to see it. So then we do that to turn them all off again, and we latch that. I think that's everything. The only thing we want to do is, at the very beginning of this entire loop, we want to pulse one other dedicated pin that is our reference to show that we're about to, you know, go through the loop from the beginning. So I need like a dedicated pin, which I'm going to call pin debug. Sure, it is just the debug pin. And what pin can I use? Let's use 11. And yeah, okay, sure. And then just gonna turn those all to inactive. okay. This pin is not gonna be going through. Yeah, this pin is not gonna be going through the inverting Schmidt triggers. So I will just instead test to see test to. Oh, this is actually quite cool. Actually, I can demonstrate just how much like wobbliness the interrupts add. So the reason I did this is because last night I made it loop just this. I removed the delay and it was just doing this as quickly as possible. And I looked on the oscilloscope and it was kind of unstable. Like it wasn't like the clocks were sort of wobbling around all over the place. They weren't lining up neatly. Every time the scope updated, they were in a bit of a different position. So then I disabled interrupts and like it was super rock solid clean and it was very satisfying to me. But we don't actually need to disable interrupts.
1,011,1,101,111 1,111,1,111 1,111,101.
Yep. I don't know what that says, but I would guess uke because the two middle ones are the same. I'm downing double cough drops. The hot shower is the only reprieve. Oh damn, what the hell? The only reprieve? I don't actually know the word. They have 3 bits declared. 3 bits declared. And it's like, I've missed so much stuff. What the hell? How much have I missed? Modern C++ doesn't use new and delete anymore. Really? And C star is Malak. Last time I went to the pharmacy, the lady asked me how many months old the infant was. I had to admit that it was for me. I just like the taste and nothing else soothes my throat the same. Oh. I really hope you're only taking it when you need to. I miss it in the US. Now I just don't leave the house so I don't get sick. Well, I mean, hey, you found a way to not get sick. I love that throat remedy things like throaties and soothers are treated more like sweets in some shops than medicines. That's crazy to me. That's really crazy to me. Is the shower helping with your cough soup? Cough soup? Cough soup sounds like a thing Nova should make. Context per U8 Login hash define. I'd have to do type def, right? Oh, is type def not a... No, type def is a thing in the C, right? That's what I'm doing. That's what I do in my standard uke standard lib for DOS stuff. My sister's a newborn and now she's sick all the time. Oh damn. I'm glad the smoke helps. Sorry, the soup, the not the soup, not the smoke, the steam. The steam. Cough soup. Is it like cough syrup but the hot tasty version? I guess so. Without it being like super sweet, I guess. I hear some people say that things like Dr. Pepper reminds them of like cough syrup or something. I really like the taste of Dr. Pepper, but I've never had cough syrup, and this makes me... Okay, it doesn't make me want to eat cough syrup for the sake of it, but I'm kind of curious about what it tastes like. Alright, we don't need this anymore. Get out of here. We're gonna need interrupts on it eventually anyway. We're gonna need to handle serial input, and we're probably gonna want some delays. Or definitely gonna want some delays if I'm gonna want to try to do the dimming of the red LEDs. I'm a little bit scared that if I'm trying to do the dimming of the red LEDs in software by keeping them on for only a tiny amount of time and turning them off, well, if the loop ends up being different lengths because we have to process more stuff over MIDI, then, you know, the red LEDs are going to change in brightness a little bit. Like, if the loop takes longer, they're going to be a little dimmer. But I can, like, try to synchronize it at a specific frame rate. I guess I should do that anyway. I should try to sync it at a specific frame rate anyway. I should make it try to achieve, say, 30 FPS. I think any higher than 30 FPS will be too fast because there are some LEDs on the very end of the board. Let me show you a render. Like with the LEDs in it. In it, bruv. Yeah, these LEDs at the far side here are meant to just pulse once and then turn off immediately. So they could just turn on as soon as the MIDI message is received, like this one, the green one for a note on or off. And then on the very next update, it can just ensure that it's off. And I wouldn't want that happening at too much higher a frame rate, because it's going to be on for such a tiny amount of time that it might start becoming like looking kind of dim, you know, and being hard to capture on a camera as well. The rate is just an example. My point was using context for it is better than define, because you're giving both linters and compilers a chance to figure out if the constant is used properly, and you get better error messages. Oh, okay. Oh, were you meaning that instead of hash define for these? I don't know. I kind of would rather just use this. I'm gonna be honest, I've never actually seen an Arduino project where people used const expr instead of hash defines for the pin things. It probably exists, but I think old habits die hard. And I think this is maybe extremely excessive when you just want to... I like the fact that this is just find and replace, because that's what I'm wanting, basically. I kind of don't want anything else to happen. I literally just want to find and replace. I'm sorry. Like, this is equivalent to me just going to Notepad and pressing Ctrl-H to do the find and replace and just typing a number. And it's like, this is how my brain thinks of it already when I'm typing a variable, or that I don't want to be variable. In other words, a thing that I want to have to find. Okay, hold on, what am I trying to do? Special debug pin doesn't go to board. We're going to pin mode. Thank you for the pads. You 50-50-ish. Unacceptable. Hi, Elg. Welcome. How are you doing? Pin debug. Output. And we're gonna write... Well, it probably already is low, but then it's gonna show us low. And then, I want to do this at the very beginning of this. Alright, I think it's all my code. Does it? Thingy, no, it doesn't. SPI class has no member named transfer 16. Did you mean transfer 16? What? Oh, transfer. Transfer. Well, I misread my own typo as well.
It was funny last time, so let's see if it works again. See if she uses.
Oh, she just held it together barely. Then you include a thing that defines the same name and everything is messed up. Okay. I tried to use names that will be unique. This is why I never name something just X or just Y, because that feels like someone's gonna have used that somewhere else. Anyway, it compiles. Let me attach a wire to the pin 11. Oh, wait, no, I don't need to do that. I can just, the probe can sit in the Arduino. Actually, if I move this to a different pin, like for example A7, I can have this on the other side of the Arduino. The analog input pin 7. One sec, I have to grab another probe. Grabs box. Here we are. I got it. I'm back. If you stick your define after includes, I think I can't have it anyway. I mean, something else could still define it, but... I guess I just don't do big projects. She says having just wasted like hundreds of dollars on these bots. Okay, I wanna ground. Why is this not being gripped by the Arduino pin header thingy? Okay, there we are. Doing things. Move the spring from the probe. Oh my goodness, I can't push this back in. Little crocodile clip thingy into the blah blah blah. Okay, pin 7, which is analog 7, sorry, analog 7, which is the debug pin. Should, hopefully, be being probed now and not fall out. Please don't fall out. I'm turning on that trace. Oh, you can't see anything yet, right? Ah shit, my keyboard cable's already tangled. No! There's too many cables around here, I swear. There's too much shit going on. Okay. And then I move this box over. Oh my goodness. Okay. Sheesh. Alright, now it's time for me to press the button and hopefully turn this back on and hopefully everything still works. Boop. It does. Okay. So we've got 3 things. We have this blue line, which is covering up the other line, which I'm going to move up there. Sure, we'll put it all the way up there. So this blue line is going to be the debug one. And the yellow one is going to be the... well, the yellow and the pink I'm just going to move between the shift registers, I guess. Well, I haven't up... oh yeah, true, it hasn't... yeah, okay. I'm pressing the button now. Boop. It's done. Nice. So we can see something happening up there on the blue pin. So let's zoom out. And let's make it trigger on the blue pin. Channel 3. Okay, there it is. Why is the trigger unfolding? Let's do... oh, I know why it's unfolding. because I was... Where is it? There it is. Calm down. It's because I was triggering on... Do you see that? Do you see how the pin is... The pulse is sometimes getting wider? Every now and then? This is the inconsistencies in digital, right? Although actually I think that's caused by interrupts, to be honest. I'm zooming out a bit further, a bit further. Okay, there we are. Now we can see like the loops. I'm gonna slide this off to the left side of the screen. And zoom in again. Hang on, where are we? Come back. There we are. So we can see one full cycle now. And now, hopefully, if I probe channel 0, any of the outputs of channel 0, with the yellow probe, then we'll see something happen immediately after that little pulse on the blue channel. Let's find out. Ooh, there is something happening. Looks a bit weird though. Oh, hang on. Wait, no, that's correct, isn't it? Also, the LEDs are looking very dim, which is a good sign. Because, you know, they should be on for just a tiny amount of time. Alright, what's going on here on the other channel? Let's have a look. I feel like something's wrong with how I'm probing it, but let's see. Just put it in the middle again. Middle. And zoom. Doesn't look quite right, does it? Oh, of course! Of course it looks like that. Hang on, this is gonna be annoying to probe then. Oh man, okay, wait. Yeah, I know why this is happening. It's because I'm probing to ground, but I should be probing from 5 volts to... Oh, and the ground should be the output, so-called output, of the shift register. Yeah. This is why I need to be very careful because the probe and, the oscilloscope and the power supply and the Arduino via my computer's power supply are all sharing the same ground. And I've already made something get a little toasty when I accidentally connected the ground of the oscilloscope probe to power supply on the board. Yep. So let's not do that again. So instead I want the positive side of this probe to be... Yeah, hold on. Gotta disconnect some things. And turn off the power supply for a sec as well. Look at all that leftover power. Hi Ninja, welcome.
Yuki's eyes a timeless glow, deeper secrets few can know. They hold a world, both vast and wide, where dreams and wonder softly hide.
Aww.
A gentle gaze, so sharp, so clear. They draw you close, then keep you near. No stars could match their quiet grace. Yuki's eyes are the perfect place.
Oh my goodness, she's really trying to make it dramatic with these long pauses. Hi Nuge, welcome. 2 probes and do math. 2 probes and do math. Does it work like that? The creative flair. Okay, hang on, I need a screwdriver. And I also need a Y. Oh no, I don't. I can use this one. I'm going to take this wire out and put it in there. And this is going to become the This is going to become the positive of the probe, not the ground of the probe. Let's not forget to change that part before I connect power again. Thank you to Posture Check and hydration. Posture Check is done. These were done before stream. This stream can't go on that long, so I'll I actually guess it could eventually go on. If I go past 10, then I'll save the kidneys again. Thank you, Stu, and thank you to the pats as well. Okay, and then this needs to go to... This needs to go to... Knees? Oh, kidneys. Oh no, I do need... Hang on a second, I'm being silly. I do need another thing. Oh my god, I almost made the sound that Fox Finale clipped and became a sound on my soundboard on my Discord server. The sound. I know this is really thrilling content right now. I'm sorry. Okay, that should do. That should do. Wouldn't you be able to probe the sinks through a resistor hooked to VCC? Probe the sinks through a resistor hooked to VCC. I'm not sure what you mean. So, VCC to resistor to probe, and then the probe also touches the constant current thing? Yeah, I guess we would see a difference there, wouldn't we? Because it would pull that down. Yeah, I guess that would work. I guess that would work. Exactly how I would connect a resistor to one side of the probe, though, I don't know. Okay, I've got this set up. Let's see what happens. It's plugged in. Camera on. And it's showing random stuff right now because it's not grounded yet. But when I touch this to there, hopefully we'll see something. We are seeing something. Doesn't quite look right though. What are we seeing? Can I just capture a single one? Well, this is just background interference from my lighting if I am brightly. Watch this. Look at what I discovered last night. I didn't really discover it. Somebody suggested it. I think it was Sandbox. Anyway, I'm just gonna turn off the lighting in my room now. Watch this. How ridiculous is that? Yeah. That's really crazy. This is with it ungrounded though, so it will just pick up stuff. And this is with it actually grounded. It'll still make a difference there. Red LEDs are especially sensitive. Yeah. This is just with the scope not connected to anything. Also, these LEDs are not flashing themselves. It's, this switching is like super... whatever. Anyway, What am I trying to do? I also tried connecting a capacitor across the output of the power supply to make sense. What am I trying to do? Okay, why can I not probe that? Why is that not working? Let me touch this to one of these. Wait, no, that's not what I want to do, is it? Is that what I wanted to do? Ah, I think I've just destroyed an LED. I have just destroyed an LED. Nice. Oh well. We have spares for a reason. I just killed an LED by mistake by sending 5 volts straight to it. Oh well. Sad. This is why it's really nice to have spares and stuff. It just becomes a lol whoops rather than oh no. But I'm not quite sure why I'm not being able to probe. Why I'm not being able to see anything. Yeah, I'm not understanding what I'm doing here, which I don't like, so I'm gonna stop doing it. Look at all that noise as I'm removing it. It really doesn't. Well, I'm not sure what to do. I can see if I can use those little artifacts as a sign that it is trying to do something, though. Probably my best bet right now. Without making up another circuit. Sorry about my ridiculously loud chair, but... Alright, so you should be able to see something again if I do this. It's gonna look weird, but at least we can see the time that it's happening at relative to the pulse, which is the important thing, and the fact that it's happening at all. There we are. There is something happening there. And it should only be happening there. It is only happening there. It's a little bit hard to see though. Oh, actually, no, that's great, that's great. Okay, whatever. We're seeing a little thing. You know what? Let me zoom in on this channel. That's probably the easiest way to... There we are. It's not the not the most graceful of signals. Can you have a graceful signal? But it is happening right after the pulse. That's pretty cool. But it kind of looks like it's happening quite a long way along, doesn't it? Like if that's x0 y0, does that look like 1/32, 1 divided by 32 of the way between those pulses? It looks quite far along to me. Okay, I'm gonna probe the next one now. But what I'm gonna do is I'm gonna keep the probe on channel 1 and I'm gonna connect the pink one. So I should refer to the colors, it's much easier to see on the stream. I'm gonna keep the yellow probe connected to channel or x0 y0. I'm gonna move the pink probe onto x0 y or x1 y0. Moving things around at the speed of sound. I'm kidding, I'm slow. Okay, now you can actually see me probing. Probema. Finally, the title of the stream is gonna come true! Okay. So... So that's the yellow one. Actually, before I do this, let me crank the sensitivity of the pink one as well. Move it up. Oh god. Wait, where'd it go? Oh, it's... There it is. Sure, let's put you right there. And probe channel 1 now, or X1. Oh wait, this is 0. Oh, this is 1! Ah, this is 1. Look, if only there were like really usefully drawn white borders around all the pins to show which shift register is controlling. If only I could have told that I was probing X1 instead of X0. Okay, let's do 0 instead. Which one is that? Okay, that is closer now. Okay, good. That's closer to the side. And let's do the next one along. Nice! Look at that! We have channel 0, and then straight after we have channel 1. Look at that! It's kind of a little hard to see. But yes, nice. One is happening, and then the next one's happening. Okay, so now I just kind of want to step them along one by one. That's that one. And now let's probe channel 2, or X2. Where is that? Yeah. Nice! Look at that! Look at that! Also, it's not only that they're happening in the right sequence, but there's only one pulse throughout the whole loop. So like, X2, Y0 is not accidentally getting addressed for multiple different X's and Y's. Do I have 20 megahertz filter on? I think is 20 megahertz. I do not. I can turn it on now. Now it's on. This is off. This is on. There's not really much of a difference. The switching of the power supply is around 55 kilohertz. I measured yesterday. The 55 kilohertz for my LED power supply, as in like my room lighting, and the power supply for the board is around 40 something, I can't remember. It was interesting though, I was able to, because I thought this noise was coming from the power supply for the circuit board that I'm probing right now, but thankfully it's not. There's just a very little ripple on there, but it's not a sharp spike, it's like a little, like a tiny little sine wave that happens every now and then. I said I'm back, not ready for my tail to be licked. Okay, this is very hard for me to see. I'm leaning over my camera right now. Next one along is... Hang on, let me move the mic. Next one along is... Channel 3. I'm very, very worried about the ground of my probe's crocodile clip, touching something random on the board as I'm dragging these probes around, but let's see. Next one is 3. Nice. So the pink is there. How are the tests going, Nuke? They've finally begun. Okay. We've got the pink on 3 and the Y on 2. And the yellow on 2, sorry. The Y for yellow. Now we're going to move the yellow over to 4. So 4 should happen after 3. So yellow should happen after pink. What am I looking at right now? What are these pins there? What are those? Oh, it's 2 LEDs side by side, and then these ones are vertically. I forgot my own board. Well, I mean, to be fair, the LEDs are meant to be on the other side of the board. And probe. Okay, yellow is happening after pink. Good, 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 good. I'm actually just standing up now and moving away from my desk and moving everything a little bit. Hold on. Gonna move things. One sec. Let's move you back. Let's move this board down to give more space for the... Ooh, why are we flashing? Ooh, why are we flashing? I don't like that. Oh, it's when I'm wiggling the wires that are connected to the Arduino. Oh god, what the fuck?
Did I scare you?
No. What the hell?
Did I scare you?
Did I scare you? I think she was ignoring all of those characters that she doesn't know how to pronounce. Welcome, Lunk. Not yet, Hakun. Not yet. So, what you're seeing here, with the LEDs dimming and flickering, is happening when I touch the wires going between the Arduino and the board. That's not very reassuring at all. What if I stop touching the probe wires and I still touch? Nope, it still happens. That's bad. What the fuck? Oh, hang on a second. One of these pins is coming out. Okay, it's in now. Okay, oh, thank fuck for that. Okay, it works now. Sorry, one of the pins had fallen out of the Arduino. the latch pin had come out of the Arduino.
You got lights, you can make lights.
I do. Okay, it's fine now when I touch the cables going between them. Oh, thank God for that. Oh! Oh! Hi, Superhaven. Why? So how was it even seeing that it was latching before? I guess it was just picking up interference from a nib, I think. Alright, next. Yellow's happening. Okay, so I'm gonna move the pink one now over to channel 5. Let's use this one right in the end. Nice. I think it's about time that I slide this camera across so that you can see the next bits, but I need to move this keyboard. Did I tell you there's too much stuff on my disk? There's too much stuff on my disk. Okay, hold on. I'm going to remove these probes so that I can move my keyboard. Where can I even put it? The only free space is on my computer, but I don't want to put it up there and block the vents. Can I balance it on top of the scope? Oh my god, what a cursed setup this is! The cable reach down to the floor? No. What if I put it there? Oh god, I can't. It's knocking the Arduino over. No! Wait, I can just balance it on top of the box with the cameras on. There we go. I was making things more complicated than they needed to be. What a surprise. I'm gonna slide this over. Where was I? I think I just did channel 5, right? Imagine having enough workspace. I know, right? Must be nice. Tetris music. Yeah, pretty much. I'm trying to balance stuff on top of... Oops, other things. Ah, shit, I'm slapping everything as I just move my hand. Let's pull this back a bit more. I'm slowly inching this board towards having more room for the probes. Groundy thingy. Who cares? Anyway, next probe. We got channel 5 on yellow in 3, 2, 1. And we have channel 6, or X6, I should be saying X6. There, on pink. Okay, nice. I can't believe this is all working so well. This addressing system is what I suspected would fail. Like, if anything was going to fail, I expected this to fail, but so far the logic is flipping sound. Alright, next. Let's get a little close to each other, but it's alright.
Yuki's hands so soft, so small, a gentle touch that says it all.
Aww.
Like petals brushed by morning dew, each movement speaks of grace so true.
Oh my god.
So delicate, yet strong in form, but quite calm, a tender warmth. No finer art could ever be planned than the beauty found in Yuki's hands.
Wow, okay, that last one is a really good rhyme though. Thank you for your kind words. I'm sorry, I'm not meaning to dismiss it by laughing at it, but calling my hands art is amusing. Especially when I'm wiggling around like this with the probe, like
because I'm holding the probe from the top to avoid hand doxing. Alright, next channel. It's a bit annoying having to move this over. You know what? Let's push it sideways a bit. Why am I evil? Oh! Dude! Thank you! Thank you very much for the gift of subterfuge. Thank you, thank you. No 2D red laser eyes? No, unfortunately not. I just go dark. Alright, so on the pink now we have the last one on channel on the Y0. Why do I keep saying channel, man? And we're going to do the first one on Y1, which is a little bit off screen.
To the right, and I'm sick and tired of moving this camera left and right, so I'm just going to do it and you'll have to believe me. Here we go. Boop. Okay, nice. Now I take the pink one and put that on Y1X1. Okay, that works. Nice! Now I take the pink one, or the yellow one, sorry, and move it to X2, which is probably going to be in view. Oh, it's just barely out of view. I'm so glad that I drew these boxes on the... I'm switching these around, the probes are getting tangled. I'm so glad I drew these boxes to show which thingy is controlled by which shift register. Holy crap, this is making this testing so much easier. Actually, you did a good thing for once. Okay, now we have Y2 on yellow, or X2 on yellow, there. And, well, I want the other probe to be on where these LEDs are, so I'm gonna have to just touch one of these LED legs, I think. I know, so lewd. There it is. I'm touching the leg of the dead LED. Look, it's still getting the power. There's nothing wrong with the shift register. But the LED is dead. Ripperoni. Okay, let's move that over to the yellow probe now. And X4 is next. Boop. Nice. Okay, keeping that on. Moving over to X5 on the pink probe, or yellow probe. There it is. Okay, my probes are now tangled again, so I'm gonna have to take these off. Why are they so tangled? How does this happen? Okay. 5. X5. X5. There you are. Look, we're like halfway towards the next... Oh no, we're not even halfway yet. Anything is done when it toasts perfect toasts? Nope. This board will not really do anything. I mean, I guess I could put it in a toaster. Like, might as well get some use out of it. Because it's not going to work probably. Okay, yellow is next there. That yellow is... X6. Let's remove this one. And pink is now going on to X7, the very last one of channel 2. And with this we'll have half done all of the tests. Or done half of all the tests. Half done all the tests. Ah! Thank you for the follow! Nuke VH? I'm not sure how to pronounce that. Ah, sorry, I keep slapping the mic with my headphones. Okay, nice. That is, those two channels tested. Or those, yes, those 2 channels tested. We are half done. And then we just have to check the special message ones. All the way over, oh my goodness, the keyboard's on my box, so I can't really move it. All the one over there. Oh god. Those two, the vertical ones over there. There's the Arduino. The probe is just sticking in it. Did I mention my desk is a little messy right now? Okay. You got German wires. German wires? What does that mean? So is my nuke? I don't know. Bye bye, Hakan! Bye 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 bye! Past Uke addressed all the addressing issues. Maybe. I'm sorry, I'm finding it very hard to keep up. Uke the smarty pants. Occasionally. We covered this at the beginning of the stream. But, yeah. No. Unfortunately. Hang on. Okay. Oh god, the wires are going everywhere. Oh my goodness. Thank you for the follow, French monkey. Monka. Okay, we're probing 7 on the yellow channel again. There we are. And we're moving down to channel 2. Oh, why do I keep calling them channels? Well, they are channels. They are MIDI channels, I guess. Well, they will be eventually, indicating MIDI channel stuff. Okay, so X0. Okay, nice. The pink is just after that. Oh my god. Now moving over to X1. Nice. Now moving the pink over to X2. This is going to be getting in view of the camera again very soon. Might need to move the camera in a sec, actually. X2, where is that? Here we are. Down there. Nice. Yeah, I'm going to need to move the camera because I need to put this right underneath the camera now. So pink is on X2. Let's resume that setup in a moment. I'm going to move this down a little bit. Maybe point it up a little bit. Let's keep the long Yukon view. There she is. I don't need to rotate this way. Focus so much on the addressing issues and board reading that she forgot to read the components. I know, that's actually true though. That's actually true. Not even a joke. Thank you for the hydration. I'll do that right after I finish this testing. I want to get this done before 10 PM. I'm using 17 minutes, although I hope to be done far before then. Okay, so pink was on channel 2. There it is. Why am I wide? And yellow is going to be on channel 3. There it is. Nice. I can't believe everything is working so far. This is amazing. Okay, I'm going to move this over to this same one. They're both... This is how they would be if they were at the same time, are they? Now let's move. Ew. Did I just spit, or is that just a bit of flux? Oh, it's a bit of flux. Okay, I thought I spat there for a minute. Okay, moving this next one over to X4. Yep, nice. It's easy for me to actually not alternate moving the probes. It's easy for me to keep the pink one on the right and the yellow one on the left all the time. Funny that makes them not get tangled up. Okay, nice. That's 5. Now 6. Let's put that. All good. And 7. All the way over here. All so far so good. Alright, final channel. Here we go. Next one, this one. There it is. And 1 all the way down there. Oh god. Probes are getting stuck on each other. Nice. That is that. Next one is 2. Sorry, excuse me. Can I just, excuse me? Okay. 2. Almost just bridged that ground to the shift register, but that's fine because it's current limiting. It would have been fine. Oh, what's going on there? Oh, right. It's so close to... We're so close to the end now that we're seeing it show up to the left of the trigger blue spike as well. Okay, that's fine. I was worried for a second there when I saw 2 on the screen. Yes, I only just noticed it. Moving over to 3 on yellow. Okay. 4 on yellow. Oops. All good. 5 on yellow. All good. 6. My probes are stuck. 6 on the yellow one now. Okay. Look how close we are to the end of the cycle. We're so close to that ending blue spiker now. We started all the way on the other side. Okay, I'm gonna take the pink and put it on 7. Oh my god, I just came so close to shorting the ground to some random thing on the board. Let's do this in a different way. 6 and 7 on yellow. There we are! Wow, every single shift register across all 4 channels is being addressed once and only once and in the correct order. Fuck yeah! Now we have to also check that the 2 message ones can be addressed. Right now they should not be. So I'm going to keep pink on channel 7. There. Let me see if I can move the camera over a bit now. I'm going to keep pink down there on channel 7. And probe one of the message outputs. And we should be getting nothing on the message outputs, actually. Let's just probe 1, controlled by the shift register. Nice, nothing. Although... that's a bit weird. What is that? What are we seeing there? Oh, it's happening on both probes, actually. What the hell? What's that all about? Yeah, there's some weird underlying... Let me zoom way out. Hold on, what's going on here? Some weird wavy thing that both probes are seeing. Let's zoom out horizontally. What the fuck is that? What is this imposter? It's not synchronized with anything we're doing as well, which is, I guess, reassuring. Let me hydrate, actually, while I'm looking at this. Okay. Sitting down again. It's alive. Something is alive. I don't know why. Jeez! The heart is beating. I wish it would stop beating. Can it beat in its own place? Beat my place. Okay, I've stretched. Let me try turning off the LED power supply and seeing if it goes away. Thank you for the pats. Although the LED power supply I thought was, you know, much more spiky. Anyway, I'm turning it off. Oh shit! Well, it was interference from the LED power supply. Wow. My lighting power supply. Well, there you go. Huh. Fair enough. Let me turn that off again. And this time I'm also going to turn off the power supply to this circuit board that I'm probing. Which will... there'll still be stuff to pick up because the signals are coming from the Arduino. Oh, wait, no. There won't be, will there? Because the address decoding stuff on this circuit board won't be being powered anymore. Let's just do it anyway. Now we wait for the power to run out. There it is. Yeah, it's a pretty nothingy signal. You're still seeing the sync passes because they're just coming straight from the Arduino. Okay, I'm plugging it all back in. Signal snakes. I read signal shakes at first. Okay, I have to change something on the Arduino now. So I just need to change one final thing. I actually should have put this down here. I forgot to do this final thingy, which is setting... I think Y is completely ignored, right? When I'm addressing the message thingies, and only X0 or X1 addresses message 0 or message 1. I think that's how it is. Let's try it. Let's just, actually I don't really care. Actually, you know, yeah, I do care. I fucking do care. What I'm gonna do is, just instead of outputting all these other ones, we're gonna comment those ones down. Well, these ones we'll keep. So now we're going to be changing the Y addresses, which should not make a difference, but you know, this is going to be a test. And then we are going to go over the 2 X addresses. But not... Oh, I guess this is within the loop, actually. Yeah, screw it, I'll just do it this way. But X is only going to go 0 to 1. And before we do any of this, we're going to do one final thing, which is turn on the special message pin. So digital write pin missing active. So now we should be seeing 4 spikes on message 0, because we're going to go channel 0, channel 1, channel 2, and channel 3. And that shouldn't make a difference at all, because the concept of channels don't exist for these special message shift registers. And it's just going to address the first one, 0, and then the next one, 1. Yeah, let's see if it works. Upload. An error code. Can we just drag in? Magically it works the second time. Sheesh! I'm seeing something. What is that? Okay, let's just zoom way back in. Oh, right, we are seeing 4 spikes. But yeah, gotta bear in mind that these are not like the correct spikes, where everything looks a bit weird because I'm probing to ground instead of VCC. But we are indeed seeing 4 spikes happening between these. Why is the, oh, it's off to the side. Okay, so we're seeing 4 spikes, so the channel does not matter. I'm only seeing 4. And hopefully, if I probe to... And this is the back of the board. I know the LEDs wouldn't normally be on the back of the board, but it's just a bodge job. Also, the LEDs have turned off now, which is nice. They are not being addressed. I guess I should test that as well, shouldn't I? Ah, fuck. I should test to see if... I need to make sure that X0 is not being addressed. And X1. Okay, so let's probe to the pink one now, and we should see spikes between the yellow ones. 4 of them between each blue one. There we are! There are indeed 4. Let me just do a single trigger so we can have a look. There we are. So we have 1, 2, 3, 4... Oh, hang on. 1, 2, 3, 4 yellow spikes. And then 1, 2, 3, 4 pink spikes happening afterwards. Oh, this is... I cannot believe this is actually absolutely perfect so far. What is happening? Does the Uke have a hub of the Git? I do not. The Nooge finds no link and would like to stick his nose in it, maybe his eyes. I don't, I'm afraid. I don't. Look at those waves. Look at them. Look at them. Okay, so now I'm going to change this. I'm going to move the pink probe. Holy Uke. I'm going to move the pink probe to probe X0Y0, and it should be doing nothing. Even though we are addressing channel 0 and X0, we've got the special message pin active, which should block the normal channels from responding. But I'm going to start probing now. Nice. It's not really doing much. It's a little hard to see, actually. Maybe I'll zoom out a bit. Yeah. The yellow trace is just so much more visible. Okay, probing Y1 X0, Y2 X0, Y3 X0. Maybe I should move the camera over to the point of interest right now. Okay. So now... Oh my goodness. Okay, I'm gonna try to neon. There you can see the reflection of my arm going across to pause the music as well. Probe is not a part of your board. You might say it was alien to it. Oh my god, it is actually alien probing. Holy crap. Wow. Have a nice sleep, Liquid. Have a nice sleep. Okay, let's probe, thank you for the pass. Let's probe... Oh, hang on, I just realized I was probing X1 all that time instead of X0. Okay, we're now probing X0. Nothing there. Channel 1. Nothing. Channel 2. Nothing. And channel 3. Nothing. Well, holy crap. not only is the addressing for everything working, but I managed to test it all. And all that got sacrificed in the end was one red LED. I didn't blow up the board or anything, or catch fire to anything. Wow, okay. Well, goddamn. It would seem that the only things wrong... Oh, hang on. Actually, I haven't tested the outputs yet. So there's the inputs down there, and there's outputs up there. I've actually not tested that yet. I guess I should do that. I was about to say that everything is working apart from, you know, the entire goddamn selection of the shift register, but... I mean, like, which one I chose. Alright. Thank you. Hi, Nintendo. Welcome. Probing indeed. Hence the title of Probema. Okay, let's probe one of the inputs. And we should see the output doing the exact same thing at almost the same time. Theoretically the same time, but Schmidt triggers will have a tiny propagation delay. We don't need this channel on at all anymore. And we can move the trigger over to channel 1. Okay. That should work. Wait, is it running? Yeah, it is. What's the voltage in perception? Oh. It's next to me. Oh, right, the scale. Hang on. I can put the scales back down to normal values now. That one. And sure, 2 volts per thingy for that one as well. And then this channel we can move down. I know you're not seeing anything. Oh, I could do it like this instead of doing it blind. Okay, so now if I put the yellow probe on one of the inputs, then whatever it's doing, we should see the exact opposite on the output, because they're inverting Schmidt triggers, unfortunately. So I'm going to probe the pin which is in the X0. So X0 is... Wait, why are we not seeing anything happening on X0? What's happening on X0? I'm not seeing anything particularly happening there. What the hell? I should see something there, shouldn't I? Should I not? Yeah, why are we not seeing anything happening on X0? I would have expected X0 to be turning on and off as we're going through this loop on the code on the left of the screen. I mean, clearly, like, X0 is doing things, right? Because unless I've just accidentally crashed the Arduino or something. Let me just reset the Arduino. So because of the inverter thing... No, we should still be seeing something. I can measure the inverted output in a... Well, I can't easily measure that, actually. It'll be one of... It'll be somewhere. What are the wires underneath? Hold on. I need to look at my own board and design. Marino's 1, I think that's a win. Let's be honest, the LED had it coming. Ah, poor LED. Okay, hold on. Let's have a look at this. Let's have a look. Oh, they connect through to ground and VCC. Yeah, that's not a useful thing to probe. So here's what I was doing. I was probing this. Why am I stretched? Good night. Sleep well. And we're probing this. And, oh, hey, guess what? The pin came out of the Arduino again. Look at it. Look at that white wire there. Not even in the Arduino. That's why we're not seeing anything coming from it. Okay, hold on. because I've got this. Oh my goodness. Man, I don't know. Thank you for the raid. It's because I've got this everything twisted around in a weird way with this to make room for the books. Hi, Manadonna. Welcome. What are you up to? I'm gonna have to be ending soon-ish. However, not yet. What are you up to? Man, oh my goodness, I can't type. Manadonna. My keyboard is in such a cursed position for typing right now. Stop! I can't even move.
Cheese.
Oh my god, I just typed it with a capital letter by mistake. Hey, it still works! Manadon, no! That was a mistake. A charity? Oh, charity fund. Oh, for your chair fund. I see. Oh no, having chair issues as well. You're in good company here. Listen to this. Oh, this is remarkably quiet creaking. It's usually much louder. Hey,
shut up.
Stop! Welcome. Why is my camera looking all the way up there? Oh, because it's supposed to be there. Welcome everybody. That's a real chair of all time. Yeah, welcome in Fizzbuzz as well. Hi, how are you doing? Welcome. Also raising money for gamer charity. Oh cool, you're actually raising money for charity. Nice. Hope you had fun. Welcome everybody, I'm a strange cat. I'm normally 3D, but my camera right now is being used to look at this circuit board, so I'm having to be 2D. This is a circuit board I made, and it's a paperweight! Because I couldn't read one enormous word at the beginning of the datasheet when I was designing a circuit. But I'm just testing everything else in the board right now. I'm gonna probe what I'm sending into it on the yellow line, and it should be giving me the same thing on the pink line, but just the opposite. Let's see if that's the case. Yellow line on X0. There it is. Something's actually happening there now. Let's zoom back in. Okay. Whew, that's kind of nice actually. By the way, that nonsense interference is just because of the bad way I'm probing, and it's coming from my lighting in my room. When I turn it off, it looks much nicer. And the way the squares are not always exact same width, they're kind of wobbly. That's because of interrupts on the Arduino. Aw, thank you, Manadonna. Yeah, I'm super happy with how the company made it. It's a shame I gave them instructions on how to make a defective board. Okay, I'm probing the output now. Boop. Alright, look at that. Perfect, we have the exact opposite on the output. That's nice. It's nice being able to see that. Oh, good. I'm curious about what the delay is actually like, so let's zoom way in. Thank you for the follow, Clank Kills. Is that a Ratchet and Clank reference? Hang on, my probes have both fallen out. Oh no, they haven't. One of them has. Oh, did I... I think I've crashed the Arduino by accidentally shorting something. Let me restart it. Oh. Well, maybe I've broken something. Oh, the pins come out again. Never mind. There it is now. It's plugged in, but it's still not working. Oh, I'm probing the wrong one now. There we are. What a mess. What a mess. Okay, I kind of want to zoom way in and see what the delay between those is like, because there will be a tiny delay. Because the Schmidt trigger has a propagation delay. Let's zoom in and see what it's like. Oh my god, that is tiny! Look at that! Wow! We can see that the signal is just slightly slower as well. It's like a little bit more curved, although it could just be the response of the Schmidt trigger. Anyway, the delay, let's measure it. The delay. Let's see, let's measure between the points where we can first see it changing. So somewhere around there to somewhere around there, I guess, is about 6.6 nanoseconds. Oh, it's so cool. So nice being able to measure these things. Ah. technology is amazing sometimes. Sometimes it's not. Sometimes it's the Internet of Things and, you know, AI blockchain buzzword bonanza. Other times it's like this. What was your board about though, Manadonna? I'm sorry, I'm being very rude. What kind of board was yours? And did it actually work? That's the important thing. Like, you can look messy, but still be clean. Okay, so I'm probing X1 now, and the input is high and the output is low. That's good, I guess. It's not a super good test, but oh, you know what? Let me re-upload the code where upload the code where the thing was going 0 to 7 over everything. That'll make all of the pins do their things. I can even make a message go inactive here. And active at the end, just so that it's changing. That's kind of useless, because we're not actually gonna be doing anything while it's active. But just so that we can see the pin changing. That's what I want to do. Upload. Okay. Let's go back to probing. X0. That's the input. That's the output. That's nice. Now let's go to X1. Alright. I'll just be like 10 minutes. Okay, someone's going to bed. So that's X1. That's X2. I'm overrunning slightly. We got Y0. Nice. Y1. Oh my god, those probes. That probe. Look at where the probe is. The ground is sitting. I'm being risky right now. It's fine. God, I don't like that at all, actually. Let's lift it up. What are we on right now? This is oh, that was message, sorry. This one was, the fourth one across was message. This is Y0. This is Y1. This is clock. Oh, look at that! This looks like really stylish, actually, and inverted. Oh, that's data. Sorry, that's data. That's not clock. That explains why it looks so weird. Data. Sorry, this is clock. I can't even speak. This is latch, and we should not see anything on this pin. This should not be connected. Good, it's not, because latches should not be passed on from one board to the other. Each board needs its own unique latch. And then we got ground here, which obviously should not be inverted on the output. Well, there we are. That's basically everything. Before I destroy something, I'm going to unplug the power. Wow, it actually works. Like everything else works. Okay. I'm going to have to call it here, because I've overrun a bit. But, thank you all very much for being here. What a cool stream setup. Like, I'm glad that it worked this time. But last time I did an oscilloscope thing, it felt very, like, a very rushed test where I didn't really show it off much, but I didn't feel like it actually worked this time. Bunch of linear power regulators for guitar pedals. That's pretty cool. Hey, at least yours works. Yours may look like a giant solder blob molten lead thingy, but white cheese. But it works and mine doesn't, so therefore yours is superior. My new CPU is very scary still. It was hitting max temp playing BG3. Oh god. That is how new Intel ones go though, isn't it? They just go as high as they can within a temperature thingy, which is like 100 degrees or something ridiculous, isn't it? No, but it's okay. The more you cool them, they just go faster. They don't actually run cooler. They just convert your cooling into performance. It looks horrible. I don't like how it looks though, but hey, mine's the same. Not when I'm running in power mode though. Power saving mode or normal mode, but in high performance. Oh really? Does it do the same thing? With AMD? You're welcome. Thank you all very much for being here. I'm gonna slide away now. Just don't say goodbye. Yes. Thank you for the pads, Exia. Hi Yama, I'm sorry I'm ending. Hi Breeze, bye Breeze. Okay, I'm gonna pass you on. I think I might pass you on to Owl, actually. This is ridiculous. Owl was streaming when I woke up and she's still going. It's been 8 hours, 20 minutes.
Yeah, just put them outside.
Owl, shush. But she's doing software and game dev. Working on Fimshes, apparently. The Fimshes on her stream. The fish overlay. White cheese. But hi, party cat. Okay, I'm gonna end now. Here's where we're going. We're going to see Owl. It's been a little while since I've rated her. I would be holding up a little plaque showing her avatar right now and giving head pats, but it's a little bit difficult when I'm 2D and I have no hands. But yeah, thanks for hanging out. When I have enough money, I'm gonna try to order these boards again, but this was really fucking expensive. And yeah, I can't be spending this kind of money regularly, so it's gonna be sometime next year. Probably looking around like March or April next year. At this rate, it's quite expensive unless I make a very irresponsible purchase. I can't be certain that I won't make an irresponsible purchase. Anyway, that's gonna be all for now. Thank you for the pads, and hopefully I'll learn from my mistakes and like actually get the right components next time. Thanks for being here, Miriam. Thanks, Fizzbuzz. Yeah, holy exactly in the Finch. There we are. Owl emotes. All right. I actually managed to do 3 streams this week, just barely. It's 22:12 on a Sunday, but yeah, that's all. All right, that's gonna be all for now. Hi, Controllo, bye, Controllo. I should probably show off the components on stream before I like decide on them as well, so other people can use their eyes and functioning brain, which I don't have, to make sure they're gonna work. I already have replacements for the Schmidt triggers, and the shift registers don't need replacing. I've already updated the board design to work with them. Anyway, right, bye. Thank you for being here. I'm gone. I can't even disappear now. Well, I'm stuck on the screen now. Okay, bye.